This video is brought to you by Greater Commons. Greater learning, greater opportunities, greater life. Visit us at greatercommons.com. So I'm going to go through the quiz once again. This will be a quiz for next week. Then I'm going to teach you some new stuff, which will also be a quiz for next week. And we're going to see how to do a web server. And then I'm going to show you a little bit of maybe database stuff that I was working on today with MongoDB. And to show you if you guys double down and do the work where you can get. And I think it's pretty cool. So I think I'll do this in our Golang web dev thing. Let's see, is that where I was working? Spring of 17, that's right. And let's create a new folder there. And this will be 09. And I don't know, we'll call it fundamentals. And inside here we'll do 01. And inside there we'll do main. And it gave it a weird package name. So I'm just gonna, is that big enough for you, Garrett? I don't know how to make this bigger in here.
That's good.
Okay. And so there's my func main. And now we could create types. So type, and then the name of the type, person, and then the underlying type, struct, and then curly braces, and then any fields I want, and first string, and any type of data I want in here. So favorites, I don't know, favorites, and it could be a slice of string where I keep track of their favorites or whatever. So there's type person, and then I can create a person using a composite literal, and it's the type and curly braces for a composite literal. And then I just put in the fields. If I just have one field, I could just put it here. But if I had a couple, I'd put them on separate lines. And when they're on separate lines, you got to have trailing commas like that. And then func.println. And by the way, I'm just kind of cruising through this. And y'all can watch this video again and then go through those exercises like we were doing in class and just work it till you got it stone cold. So that's everything I'm doing. I'll tell you when I'm done doing the stuff that you don't need to know for next week, and but everything we're doing you got to know next week until we hit that stop point, and I'll tell you when we hit there. So I'm going to launch my terminal and go into, and it's 46 and then 0901 and go run main.go. And that should print out something. It should print out a cloud. And I could also print it out like that. So that printed out that entire struct, right, between curly braces. It's a data structure, thus the name struct. And I could also print it out like this, where I call a field, and that's dot notation. So this value is that of type person, and type person has these fields. So I could say, hey, this value, give me that field, and it'll give me that field. And it gave me that field there. So the top one is the entire data structure. There's only one thing in it. The next one is the field. Okay? So that's that. And then to attach a method to it. So we do a function. So if I just had a function, like this would be my normal function. And so it's function and then some identifier, and that's the identifier. And then here are the parameters, and then here are the curly braces where you put your code. And you're just going to put statements in there, like, hey, print this, or add these numbers and assign it to this value, or whatever. You're just putting statements. And so if I want to make this a method, all I do is pass in, all you do is use a receiver. And now I've attached this function to any value of type person, and that's called a method. When you take a function and you make it a method. And you do that with a receiver, and a receiver acts, this thing here, right there, acts pretty much just like this thing right here, right? So any values that we had there, except we wouldn't be passing, we don't pass person in explicitly. So if I created a different func, let me just show you what that looks like, numpy, whatever, right? And this took a int, and then it just printed out that int, and if I call numpy and pass in an int, right? So here numpy is being called. I pass the argument 42 in because that parameter has been specified. So that gets assigned to n. The scope of n is here, so 42 got assigned to n. And then I could use that that variable n inside that scope. Okay? Well, it's the same way with, so that's a parameter, right? Parameter. And when we have a receiver, that's just like a parameter. It's like another value is assigned to that variable, except when it's a receiver, we don't pass that in. And so it would be like p1 dot person, sorry, p1 dot speak, right? And then I'm going to have speak do something. Right? And so here, just move that down a little bit. Here, p1 is a value of type person. If you have a value of type person, then this method is attached to any value of type person. So p1 has that method available. So I say p1 speak, just like p1 has this field available. Right? Fields are like an object-oriented program. They talk about what does it know and what does it do. And knowing is like data, like here's data about this object. A car object, classic programming example, is like, how many doors does it have? What color is it? Is it a sedan or a truck? And those are things it knows. That's data about it. So this is data about it up here, these fields. It's got this, it's got that, giving it pieces of data. And then what does it do are methods, right? And so you would, create this template in programming, traditional object-oriented programming, and I'm referring to it as traditional because Go is iterated and evolved and innovated on programming, and it's kind of taken a little bit of another next step when it comes to programming. And so OOP's been, reigning for 15, 20 years longer, something like that, but now there's like a new way. And so with OOP, right, like an object, what does it know, what does it do? It's got data and it does stuff. And so you'd create that blueprint, that template, car, and then anytime you needed a car, you'd say, give me an instance, give me an instance, give me an instance. And you just, okay, it's like a blueprint. You just manufacture new cars anytime you need a car in your program. So if you're building a video game, right, you'd have, cars driving around. And you don't write the code for each of those cars. You write the blueprint, and then you say, give me another instance, give me another instance, give me another instance. You've written that car code once, and you change the data a little bit. You say, well, the color of the car, this car is blue. The color of this car is red, right? And this car drives. Now would be a method attached to the car. So here we're doing OOP stuff, kind of, and it's like type person with data, what does it know? And then also with methods, what's it do? And the point being is that here, right, it'll take arguments there, but this is the receiver which attaches it to a type. And then this is just like an argument except you don't pass it in. So I do P1 speak, and then P1 gets assigned to P, right? And the scope of P is here. Just because I used it, P1 is just built in the language assigned. So P is here, and then I call first. And so when I do this right here, it's going to do the same thing as right here, right? It's just going to print out the object's first name. What is the object? This is like the instance, right? I have the blueprint, a person, and okay, give me one person, right? If I wanted to, I could get another person. I'll just bring this up to 2-line to make it a little bit. I could do another person, right? And P2, and then I could attach that method to the second person. I'll just get rid of these lines for now. And then, here's the blueprint, and here are the instances, right? Give me a person, there's one. Give me another person, there's another one, right? And then they each have methods, and they run. So this will print out both their names. So that's creating structs and attaching a method, and got to know that next week. Should have known it this week. So the next thing is just like working with slices, and we'll come back to this in a second. And I'll just leave that the way it is, so you can look at that one. And we'll do O2. And then in O2 here, we're going to get rid of that and work with some slices and maps. And we'll use that. So a slice of int, composite literal, we have the type. And we saw that when we were doing the person, right? The person was give me the type, curly braces, and then the values. So there's the type, there are the curly braces and the values. So now composite literal, the type is going to be a slice event, and that's the notation for a slice, or those brackets, and curly braces, and then the values and commas. Though I messed up. And then I could print that, and that'll run, but I'm not going to run it, and I'll run it in a second. And I could also range over it for index value colon equals, and those IVs could be any variable name you want. I just use IV because it's the index and the value, and that makes sense. Range over xi, right? And then funct print line index and value. And so the index is on the left, 0, 1, 2, 3, 4, 5, 6, and the values are on the right, 4, 3, 5, 7, 3, 4, 5. And so that's it. That's the range. So you just got to know that. You got to know that range. Okay, know that next week. All right, so work it. Do it 20 times every day. And by the time you come to class, you're like, I'm ready to move. I'm ready to move. Let's move. So that's doing a slice of int. And now we could do a map and a colon equal. And it's map, and then some sort of a key, and then some sort of a value, and then composite literal. We got the type, right? And then we have the values, and so the values will be like McLeod 42, Bond 32, and then I could print line my map, and I could do my for. And a map is a key value, so same thing, just different identifiers, right? Nothing special. And map and slice, when you range over them, they work pretty much the same. And so now I run this. There's the map, McLeod, Bond 42, and then it prints out the keys and the values as I range over it. Okay? So that was like the quiz at the beginning class. That you should. I'm sitting here on video picking my ear hair. How weird is that? You get old, dude. Like the hair stops growing on the top of your head and starts coming out your ears. Gets all confused. Got something to look forward to. Better hope it happens to you. Otherwise, people will be saying things at your funeral. And so that's that stuff. And then the next piece, which I want you guys to be exposed to and grok, are interfaces. And so an interface is if you have some kind of, so interfaces define behavior. So let me just talk about interfaces for a second. You already use interfaces, you just don't know it, right? So if you needed, how would you, what's something that, if somebody's they're wild, man, that dude's wild. I partied with that guy one night, man, he is wild. Like what comes to mind as somebody who's wild? What do they do?
Wake up and yell the next day.
Huh? Okay, they're loud. That's a good one. They drink a lot, right? Right? So anybody who has those behaviors fulfills that interface. Right? The wild interface, if you have the behaviors of loud and drinking, man, you're going into that category. You are of type wild. You're wild. Like, how many times you said that to somebody? Man, you're wild. Right? Like, they fulfilled some interface in your head defined as wild because they had certain behaviors. And you said, you're wild. What about if somebody's a tough guy? Right? Tough guy interface. What kind of behaviors do they need?
Aggressive.
Aggressive. Attitude. Right? And then you're somewhere and you see somebody smacking off at the gas station, somebody else, and you're like, that guy's a tough guy. Thinks he's a tough guy, like under your breath because you don't want him to come over and start talking smack to you, right? You're like, this guy thinks he's a tough guy. But he fulfilled the tough guy interface. There's certain behaviors he has. And you say, oh, you're of type tough guy, right? And so interfaces define behavior, and we already use them. Give me another example of an interface you use and the behaviors it defines.
Anal retentive.
Anal retentive interface. What are the behaviors to fulfill the anal retentive interface?
Struct.
Strict, right? And orderly.
Obsessive.
And a little obsessive. Hey, make sure you put that away if you take that out, right? So strict, obsessive, right? And then they fulfill the anal retentive interface. And you see somebody with those behaviors, you go, man, that dude's uptight. Anal retentive. And so it's the same thing here. Interfaces define behavior. Type, and then we give it some sort of an identifier, human, and we say it's interface. And then we give it curly braces. So just like type, person, struct, right, where the first thing we're defining a type, and then we give it a name. And this is the name of my new type, and then we tell it the underlying type, the thing that falls after it. So type person, the underlying type is what? Type person, the underlying type is what? Struct. Type human, the underlying type is what?
Interface.
Interface. Okay? And I had type hot dog up there earlier, and the underlying type was in. So we get to create types in Go. And that's part of how we get creative and build stuff. And start doing like black belt jujitsu coding things, which people are like, whoa, check you out. Because you're fulfilling the coding interface. Coding interface has behavior of black belt jujitsu coding ability. And you're like, whoa, man, you're fulfilling the coding interface. So interfaces define behavior. And so we could say that anybody who has this method is a human. Cool, man, you speak, you're human. Because I ain't ever met a dog that talks. They bark, but I've never met a dog that talks. I ain't ever met a shark or a snake or a rock or a boat or, oh, I was going to say a car, but cars do talk. Let's put talk and walk, right? Okay, you got to have two behaviors to be human. You got to talk and walk. Okay, now you're human. But we'll just leave it with speak. Okay? And so now, P1 is of type person, and it is of type human. Woo! Check that out. P1 is of two types. Just like a person could be, type human and type tough guy, they could be of two types. Or type human and type anal retentive, they could be of two types. We create programming languages to model the real world as closely as possible. Right? Values can be of more than one type. This allows us to do some interesting things with our code to make our code more reusable. So what can we do if something is of two different types? Func and foo, I don't know what else to call it, is going to take in a human. And then we could just format print line H. Cool. So now we could do foo H. Sorry, foo P1, because that's a human. And both these people are humans because they have the method speak. Right here, type person has the method speak. If you have the method speak, you're fulfilling the human interface, baby. Woo! An interface says, baby, if you've got these methods, I'm your type. No, you're my type. An interface says, baby, if you have these methods, you're also my type. No questions. Oh, hate that. Your teeth grind together. It's like chalk. Fingernails on the chalkboard for me. Foo P1, foo P2. They could both go in there because they're type human. That's what this wants. And I'm going to run it, and we're in O3. So printing out McLeod and Bond there, right? Get rid of those for a second. Now the thing that's interesting about that, this doesn't have to make logical sense. Or we'll do this. What type is this? What type is C1?
Car.
Cool. What else?
Struct.
Underlying type struct. What else? C1 is of what type?
Technically human.
It is human. C1 is human. Why? Because C1 is of type car. Type car has the method speak. If you have the method speak, you are also this type. And so now I could do this. Woo-hoo! And that's what people in computer science call polymorphism. Poly many, morph change, right? I could have my code do different stuff. I could have it take in different types. If I run it, red, prints out the car stuff. So that's those are interfaces, and you got to understand the fundamentals of interfaces. You don't have to really use them a lot. You just got to understand, like, oh, it's an interface. If you have these methods, you're its type. Like, you got to get that when we start talking the web programming thing. So funny when you teach programming and you like kind of bring concepts. Okay, you guys following me, and then all of a sudden you're like, okay, I'm gonna have to meditate on that one. Like the room gets still. So you're gonna be responsible for, like, I want you to be responsible for all this. I want you to do it next week. It's not that bad. It's just like, oh shoot, okay, I define type person, it's a struct. You know, I define type human, it's an interface, and if you have these methods, then you fulfill that. You're also that type. And you know, type car, it's a struct. I attach the speak method to person. I attach the speak method to car. Now they're both got the speak method, so any value of type car, type person is also type human. I create a function to take type human in, and then I do all that. This code right here, 03, you got to recode all that in class next week. Okay? Because what I want you to get to is being able to do things like down here, and we're going to jump through a lot of this stuff. If you are diligent and if you have the desire and if you want to get to a 6-figure income, which you could be there in 2 years, you will take my Golang Web Dev class. And you've got the URL for that, but if you're just watching this video on whatever, YouTube, go to greatercommons.com, and there's the URL. And it should be up in a couple of weeks. You should be able to get the course there. And if it's not up yet, you could go to Udemy Todd McLeod. And at Udemy Todd McLeod, you'll find my Golang Web Dev course. But go take that class and start working through everything. And then by the end of it, you know, when you two-thirds of the way through it, you'll be able to do stuff like right here, MongoDB. Like totally sweet, man. Like here's Mongo. You know, and I go to Mongo, launch a new tab, and I say, hey, man, I want to run MongoD. Fired up! And then I got to get my Mongo terminal going. Fired up! And I have no access controls here. And so now I can say, show DBs, show me my databases. Sweet. And I want to use my store. And sweet, now I'm in my database store. And then I want to see, show all my collections. And oh, sweet, they're all my collections. And then I want to see, okay, this database, list out all the crayons for me, you know. And it's like, okay, sweet, they're all my crayons. Right? And that's looking kind of like a struct, you know, where we have fields and values, right? So each one of these is an entry, a unique ID, and then the field hex gives the hex value, the name gives the name of the color, and then the RGB gives the RGB value. And it's like, what else do I got there? Let's check this out. db.oscars.find. show me all the Oscars. Heck, that's a lot of Oscars, boy. Yeah, it's every one since like 1926. And you could go through here and you could start to say, oh, well, how does that query stuff work? And this is the kind of thing where you get your teeth into it and you're like, oh, man, I can't let this go. I'm going to be up all night fooling with this deal. This is crazy. And I'm just looking here to pull some of these things out because they're all pre-written. Index lid, projection. Well, I thought it was in there. This is what I need right here. And I'm just looking. I want to bring out like the Oscar one. Let me find it. Hang on one sec. All right, so it's 10 sort, right? But I could come in here and like grab this, copy that code. So find, and then the release year is greater than 1980, and just give me the year and the title. And so then I can come back here and I can clear all that out, and there are the years and the titles of the movies that are Oscars. You know, it's like, that's a power. That's some power. And then you jump all the way down here to this last one where we wired up with Go and Mongo, and that's 16, 46, 16. So I'm going to just come back to this one and change directories out of this stuff and go into 046. Where am I? Go up one more level, 046, 16, and go run star.go. I'm firing it up, bum, 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 firing it up, bum, 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 firing it up, bum, bum, bum. I'm firing it up. 6-figure income, take care of your family, get a nice car, have a nice house, don't live in dangerous places. You know, localhost 8080, all my books. Let's see one of the books. Oh, okay, there's one. Let's insert another one. And to do that, I'm going to copy this crazy thing. Let's insert a book, you know. And the title would be like, yeah. What's the title of a book that I like? A Path with Heart. Jack Cornfield. If you haven't read it, it's great. It's probably going to cost you used on Amazon $8.99, probably less than that. And okay, create a new book, Jack Cornfield, all books, sweet, there it is. Oh man, the W needs to be uppercase. Update that, submit, cool, all books, and it's like, yeah, nah, let's get rid of it. Like you guys, if you pay your dues, you'll be there. But you got to step up, and we're going too slow. You're going too slow. Do the work every day, an hour. Not because you want to grade, because you want to do something with your life. I've got a pathway. I know the pathway. If you follow it in a year and a half, 2 years, you could be making $100 grand. I don't care you don't have a bachelor's degree. You come in and rip that up, people would be like, shit, he could code like a rock star. He fulfills the coding interface. Hire him. He is a type coder. But immerse yourself. You got to do at least an hour a day. And, probably 4. Like, do 4 a day. Just sit down and bang, a bang, a bang, and that's the work. And then all of a sudden it starts unlocking and you start speaking it. Like, who doesn't want that? That's not much. That is not much to get somewhere. All right. So I'm not going to show you the other stuff because we're out of time. I'm going to take roll. I'm going to give all of you except 3 of you who raised your hands an F on tonight's quiz because you failed it. And then next week you got another chance. What are you going to do? Practice. Is it going to be arduous? No, it's going to be fun. Enjoy it. And when you're frustrated, know that that's it. And don't stay frustrated. What am I doing wrong, man? Can you do a hangout with me for 5 minutes? Yeah, what's up? Let's hang out. I'll do a Google Hangout, look at your screen, you'll be like, what's wrong? I'll be like, that! You'll be like, thanks. All right, see you. So just email me. You got my email. If you're stuck for more than 10 minutes and you can't find the answer, what's wrong with this? Why is it not working? You got this video, watch it again. Otherwise, just stop. Just quit this class. Because you either do it, like Yoda, right? Either do it or you don't do it. Do or do not. There is no try. Like, don't even waste your time in here if you don't want to like do it. And if you want to do it, do it. Let's do it. I mean, you know, unless you're just like, this is a little interesting and I'm fine to sit in here like watching TV. Todd's kind of funny and entertaining. And, you know, and then I'll just forget it all. You are learning the best programming language in the world to know today for learning web development. You're learning it ahead of the curve before the hundreds of thousands of other people learn it. It's starting to hit. You could get in early and you could make your future. All right, pack it up. See you guys. Oh, I got to take a roll.